So yeah, we're going to look at templates. I'm going to do a quick recap on how templates work. Anyone who already knows NSO will probably know what I'm going to show there, but if you don't, it'll just bring you up to speed. Then we'll do a quick run through some of the template features, and I'll call out some of the newer ones. I'll show a little example in the slides, and then for the rest of the session, I will do a demo, and we'll build a few templates, and we'll test them against some live devices. So hopefully that will go okay. If it doesn't work, you'll get the idea anyway. Okay, so how templates work. I've shown some of these slides previously. I'll just run through them quickly. They're just a good way of showing an overview. So within a service, a template-based service, we have a service model and the template. You can think of the model as your input parameters. So we may have something like a VPLS service. We go in, we create an instance of that service, we fill some parameters in, and that service is associated with a service point. So when we commit, NSO will execute anything that's registered on that service point, and that's where we register our template. So the values from our model can be substituted into the template, and the template generally has the sort of shape of the device that you're wanting to apply it to. So that template, which can be multi-vendor, so within your template you may have snippets for each different kind of device you want to support. And when it executes with the substituted parameters, the result of that template is merged into the device models in NSO. NSO then takes those models and it calculates a minimum diff. So anything that's actually changed as a result of that template will result in a diff set. And that can be, again, for different vendors. There'll be a different network element driver for each vendor that will take that diff set finally and calculate the least disruptive change to push it to the network. And then that one important thing, which I'll probably reiterate later as well, is that your service will usually span multiple devices. So it'll be a network-wide transaction, and it may result in configuration for multiple devices that you'll get the transactional guarantee that is applied to all devices. So that's a very high-level view of how a template-based service works. How do we create one? So usually we'll start with some example configuration on a device. We'll sync that into NSO. So the device models in NSO will have an example of our service on there. We can extract the bit we're interested in into an XML document, and there is a new feature to do that, the display XML template feature, which we'll look at in a minute. And then from that XML document, this is sort of an iterative process, I suppose. You'll look through that, identify the parameters you're interested in, and create a service model from there. And then you'll update the XML document with the parameter substitution to give you the template. And this is what we're going to do. I'm going to do a demo to create one of these and show how it works. So within our template, you think of it as an XML version of the configuration we want to generate with some parameter substitution, but there's also some extra features in there. There's processing instructions, so we can set variables. Anything we put between squiggly bracket is just xpath, so we can use any functions we want in there to calculate some values. We can do conditional statements and for loops. A lot of these features have been around, some guys for a long time. The else if is fairly new. That only got added, I think, in 6.2. So if you're using NSO from before then, you can streamline a little bit with the elif statement. Something slightly newer came in, I think, 5.6 maybe, towards the end of the 5 releases, was the ability to add macros. So this is where if you're repeating the same bit of configuration often, put it into a macro, and then you reduce a lot of duplication. A good example might be if you've got a service that maybe configures like a connection, an E-line, or a pseudo out, some point-to-point thing where maybe you've got an A-end parameter and a Z-end parameter, you can write a macro, to configure the interface on either end, then expand that macro twice, right, for either end, rather than having to write everything out twice. There were ways to get around that in the past. You may choose to apply the template twice from your Python code, but now you can do it all inside a template with a macro. As I mentioned, there's a new display XML template feature. So this will give you, from some configuration in NSO, it will give you the template. So you can take that template, paste it into your service, and paste it into your service, and you're good to go. Then you just put your substitutions in there. And finally, one other new feature is you can now do new, I think this just came in 6.4, you can now have templates for pre-modification and post-modification callbacks. So previously that had to be Python code or Java code. It had to be code because you couldn't register those callbacks from a template. So they're used if you want to apply some configuration that NSO is just going to sort of apply and then forget about. So if you're normally NSO will track everything it did and clean it up and remove it, but there may be something you want to do that you don't want to get removed if the service is ever deleted. So for example, if maybe you need to turn on a feature in the router to support whatever you're doing, whether it's L2 layer 2 configuration or something that you want to make sure is enabled, but then if your service is ever deleted, you want it to stay there, you would use a pre-modification or a post-modification callback for that. Okay, so let's jump into an example. I did play around with some different examples and I tried to look at what is still getting used quite a lot, and I didn't really want to do a layer 3 VPN because we see that up quite often. So I've chosen to do a VPLS. It's been around for a while, but I think it's still used quite often. So a super simple VPLS service, no BGP signaling, just LDP. So we need a full mesh of neighbors. This is the configuration we'd want to generate. So we would start with, on Cisco, a snippet of the configuration. So this is how you might configure your VPLS service on Cisco on one device with two neighbors. And then what I want to do from here, as we saw in the slides, the slides earlier, we identify the substitution variables. So the first thing I'm interested in here is perhaps the name. So for the bridge domain and the VFI, I'm using the same name. So maybe I'll make this the name of my service. So I want to think about these substitution variables and how I'm going to put them into a service model. So from here, I'm going to create a service model. So I'm going to have a VPLS service, and one of my parameters will be a name. Other substitution parameters I can see in here is the interface. So this is a customer-facing interface. I want to make that an input in my service model. I've got the neighbors. So what we need to think here is that the VPLS service is going to span multiple devices. So for each neighbor, I want to look through the list of devices I want this service to apply to. So I may have a parameter called devices, and this can be a list of devices. And then for each device in that list, I'm going to want to generate a neighbor. And then the pseudo wire ID, again, will also need to be an input. And what we can do, we can look at sort of this graphic and how that would translate to an actual bit of Yang in the text. So we would start off, services are almost always a list because we want to be able to create more than one. We'd have our name as a leaf, which would be string, and you always need to identify a key for a list, so the name would be the key, and then there's a couple of extra lines you need here, which is generated automatically. The main thing is the service point, this VPLS, so when we create our template, it'll have a matching service point, and that's what is executed. And then we need this user statement here, just so NSO can store the extra data it needs for the service, internal stuff like the devices is modifying and LAN data, etc. Our customer interface, that could be just an integer. Maybe I only want to store like the last bit of the number. That's just a standard leaf. As I said, the devices, it's going to be a list of devices. So because there's only one item in the list, I can just use a leaf list. We can use a leaf ref. So this is the path to the devices in NSO. So we can easily validate and select devices from the NSO is managing to add to this device list. And the pseudo wire ID can also be an integer. That can be a big number. So make that an unsigned integer, 32-bit. And that's how our service model could look for that piece of configuration. So with that, I'm going to go and actually create that live. This is the environment I'm going to use. So these are virtual devices, but they're running on a real hypervisor. I've got 4 nodes around the edge here, these 4 PEs, 1, 2, 3, 4. They're all Cisco devices. They're connected to these CPEs, 21, 22, 23, 24. And then we've got a couple of Juniper devices too. If we have time, I'll make this a multi-vendor service. And they're connected to 29 and 30. So these guys are all running, it's an IGP here, ISIS, so they've all got connectivity, they can ping each other, and then out to the CPEs, there's a interface connected. On all the CPEs, it's interface 1, and for now they're all configured in 10.1.1 subnet. So CPE 21's .21 and CPE 22's .22, etc. So you can imagine maybe these are all customer sites, for a customer, and he wants to get connectivity between all these. So we can create our VPLS service, and then everything should be able to ping on that subnet. Right, so that's my environment. I have an NSO instance running. Let me log into it. So I call the NSO instance. I could have actually had a bit more time. I could have created a brand new NSO, but I've already created the NSO, and I've onboarded the devices in here. So these are the same devices. We've got the CPEs, which are iOS devices. We've got those nodes that are XR, and then a couple of VMX Juniper devices. Let me open another window up here. If we look at what packages we've got installed, I've got packages for the network element drivers, and now I'm going to create a new package for this VPLS service. So we'll use the NCS make package command. It's a template-based service. I'm going to call it VPLS. Let's go into there. We'll have a look in VI. So this is the structure that it creates for us automatically. We've got the YAM file. And then also I'll open the template that it created, the skeleton. So what we want to do is exactly the steps we just looked at. I'm going to take a sample of the running config. I'm going to use the new display XML template feature and paste it into here. So let's go ahead and do that. So the first thing I need to do is actually configure that bit of configuration on one of the devices. So I'm just going to go ahead and take that config straight from the slide, actually. This is as good a place as any. So this bit of config here, this can be my example. I'm going to copy that. And what we'll do, we will connect directly to, let's put it on node 1. So the IP address for node 1, 198.18.141. We're going to go ahead and paste in that configuration. So now we've got an example service configured on node 1. So if in NSO, we should be able to see that node 1 it's not in sync anymore. If we compare the configuration, it should show us the config that NSO doesn't have that I just applied onto node 1, if it's working okay. Okay, great. So I'm going to synchronize that into NSO. Node 1 sync from. And then we'll take a look at it in the NSO, NSO's CDB version. So devices, device node 1. It's under the config and it's L2 VPN. So that's it in NSO, and now I can use this new feature. So it's the pipe display option. I hit tab, you've got lots of different options here, but this XML template feature I want to use. So I can get the XML template straight away. And here it is. So I'm going to take that, I'm going to copy it, and I'm going to paste it straight into here. I've left the top in here because we need the service point. That's already written in here. VPLS, this is what matches the service point in the YANG model here on the left. And this is the template. So all we need to do now is go through this template and fill in the substitution parameters. Now again, I mentioned this a couple of times, but this is an example bit of configuration of how it will look on one device, but our VPLS service is going to be applied to multiple devices. So on the left here, we already have, so in the skeleton, you get a name, which I'm going to reuse, and we get a list of devices, which I'd rather call devices, so that it's not plural. Get rid of that comment. And I'm going to use that list of devices as an identification for which devices we want to apply the config to. So one nice feature with templates is if you're setting a list key, so here, a list key value, and the result is already a list, then it will apply for every item in that list. So if I just put devices in here, this sort of configuration will now be applied to every device that we've input in the service model. Now, an important concept in templates is your context. So anything we write in a squiggly bracket is an XPath, and it's relative to the current context. And the context starts in these template-based services with wherever the service point is. So everything I'm putting in these squiggly brackets is relative to this service point here. So that's why I can just type devices in. Now, when something's looping round, this is going to loop for every device, the context is switched to the current iteration. So everything below here will now be the current device inside this leaf list. So that's important to understand. So the next thing that I'm going to want to substitute in here is the name. Right? So I want to be able to name I don't want it always to be called VPLS1. So I'm going to change this the name, but because my context will be inside the current device, I need to go up to the name, or I can also use just / because the root, when the template initially executes, the root context is the same as the service context. So I can do /name. Now again, what would happen here, because this is the disposition remains a list entry, is the context would then switch, which usually is quite useful, but in this case I don't want it to switch. So I'm going to put the string function here. So this means the result of this xpath is just a string rather than a node, so it won't switch to it automatically. So we're still inside the device context. So for the customer interface, again, I will fill in we'll use this dummy here, I don't need, we'll call this customer interface. And I'll make this, I think we said a uint 8. You could make this a string, so you could type the whole thing in, but I'm just going to fill in the last part of the interface, make the inputs easier. So this service is always going to apply to gigabit Ethernet 000/ whatever you choose. And again, because we're in the current device context, I need the / to access this leaf. Same here, the name is the same as what we already have. And here's where it's more interesting. So I want to generate the neighbors. So I have a list of devices here. I'm going to be iterating through. So I'll be on a particular device when this executes, and I want to add neighbor statements for the other devices in the list. So here we can use the for each, which is one of the template features we looked at. I want to access the devices. Again, I'm inside a particular device. I want to go / devices. And then this will now loop. So within this XPath, this will be looping through each device. And I want to say where the device I'm currently looped through does not equal this device, right, my current context. So I can use the current xpath function to get the current context. And what that will do, that will now loop through every other device in the devices list. Let's delete that. And what we need to get in here is the loopback address of the other devices. So we need an xpath for that loopback address. And we can do that in the CLI because there's a useful display function to give us the xpath. So I'll get the one from, say, node 1 config. So I want to get the xpath to the loopback interface address. So we've got here, it's IPv4 address. Yeah, and I can use the display option. And there's one for xpath here. So this will give us the xpath, so we don't need to worry about trying to figure them out, which can be slightly more complex when you're looking into a device model. So I'm going to take this guy here, right, the xpath to the actual IP address. I could paste it straight in here, or I could put it in a variable maybe. Let's use the set processing instruction we saw on the slide earlier. I'll create a variable called loopback. Just make this window a bit bigger. Paste that in. Now what we want to do here, so we will be within this for each loop. Again, our context will be the neighbor device that we want to get the loopback address for. And if we look here, the device is actually a leaf ref into the model. So we can simply, we don't always apply it to node 1. I can use the deref function. And I can deref my current context. And that will take us to this point in the device model. So the leaf ref points to the name. So I need to come up one level to get out of the name and into config. And then the neighbor, I will set the loopback address in that variable. And then finally the pseudo RID. So let's just add another leaf for that. Again, we'll make that 32, so we can put a big number in there if we want. And let's just fix the indenting there. Pseudo IRID again, because we'll be in the context of the device. I need to put a / because it's at the root of our service to make sure we can access that properly. If you have any problems with this, when you test the service, you can use the debug template feature, and it will show you exactly how it's calculating these xpaths, so you can root out mistakes quite easily. So I think that looks pretty good. And that's it. That's our service. So that will now allow us to create VPLS services across multiple Cisco devices. So what I want to do is compile the YANG model. It compiled okay, great. And then inside NSO here, I'm going to reload the packages. So that VPLS package I just created will get loaded in, and then we can test it. So I guess one important thing to understand is what I have just done is I've sort of, as a developer, I've added the ability for NSO to now provision VPLS services. I don't need to do that every time I want to provision VPLS. Once I've created that package, I can give it to someone, and then anyone else, a network operator, can go and use it to create their own VPLS services. So what I'm going to do to test this, I'm going to open another window up, and let's connect to some of those CPE devices. So let's open a couple of windows here. So I'll connect to, say, device 21. And from here, we can try and ping, say, 22. So 1.1.22, and I'll repeat it a few times. So it's not going to work at the moment, so there's no connectivity there. And just to show we're going to get like a full mesh of connectivity, I'll pick a few random ones. So connector 23. And say from 23, let's ping 21. And I will also connect to, 29 and 30 were connected to the VMX devices. So I will connect there, and if we have time later, and I get to enhance the service, we can test that too. Okay. So that's taken a few minutes to reload this. My laptop's running a little bit slow at the moment. But yeah, once this is reloaded, we can imagine that right now I've taken these packages and I'm loading them into maybe my test environment. I'm going to test them, and then once they're good, we'd use them and load them into a production environment. Now, since I've already created this bit of config on node 1, when we go and test this service, and if I put, say, let's run the VPLS on nodes 1, 2, and 3, we'd expect NSO not to generate any configuration for node 1 because it'll already be there. And hopefully it's going to finish soon. I'm actually running NSO inside a Docker container here, so there could be some slowdown with how it's accessing the disk. Okay, that looks pretty good. There are also some newer features in NSO for like hitless upgrades, so you can add NEDs without doing a full package reload. And once we've reloaded this package, once we've loaded the VPLS package into NSO and it's there, and if we're not updating the YARN model, you can use the package redeploy option just to reload changes to the template, which is what I'm going to do. So let's test it out. So I can now create a VPLS service. I'll call it VPLS1. These are all the options. So customer interface. So this is getting generated from the YARN model I just loaded. I can also set sudo IRID to 3. And then devices, we'll do node 1, node 2, and node 3. I try run. And we can see that it's configuring node 2 and node 3. For some reason, it's not added the neighbors. So that means there was a mistake in my xpath. So this is good, shows that this is real. So what I'm doing in here is looping through every device that should say does not equal current. My bad. Let's reload that. So we can use the redeploy feature here. Test it again. Still didn't work. Test again. Let me have a look. So for each, so we're saying here for each device that does not equal my current device, DREF. Let me just check what I have here. I do have one that's already done and working. Name devices is not equal current. Okay. Let me just devices. I don't expect this to work. Let me just try one more time. Okay, let me copy over the one I know that works. Just give me 1 second. Oh. So this is annoying. I can't see why this isn't working properly. So what you can do, this is a good example. I can show you the debug option. So you can debug template, and this will show us everything that is getting evaluated as this template executes. So you can see that it's going through each node. It's evaluating things like the interface ID, and then got for each here. So this is the guy that's not working for each device. I should say devices, shouldn't it? That was quite a stupid mistake. So you can see in here, it's saying that it's evaluating this and the result is empty. So that's where the problem is. Let me I already committed it there, didn't I? Let me let's get modifications. So this already got committed. What I can do is I can, when I did the debug template, I can just well, interestingly, so this has been committed now, so it's on the devices. And if we look at my pinging, we'll see that it's still not connecting. We've still not got connectivity. So that's because there's one other piece of configuration that is needed. So we look under node 1, config, interfaces. On customer facing interface, there's an extra piece of configuration here, which is L2 transport. So that's something else that we need to push, but that is something that maybe we want to just ensure that our ports are all have that L2 transport statement, but we don't want them to be part of the service. So this is a good example where we might create a pre-modification template for this. So I'm going to do that. I'm going to simply again use the display XML template option. I just want to get the L2 transport. And I'm going to create a pre-mod template using just that. So if I go back over to our service, so this VPLS template, I'll save another version of it, VPLS template, pre-mod XML, oops, VPLS template, pre-mod. Let's refresh that. And then I'll paste that in. And to do this, as we saw in the slide earlier, we just need to say that the callback type equals pre-modification. And we want to run that on all the devices again. Now we can also look at the operation, so we might only run it on a create or an update, but just in the interest of time, I will run it, just leave it to run. Not customer interface. Right, so let me reload the packages again. And what we should see now, if I redeploy that service, so VPLS, redeploy, whatever. It's going to add the L2 transport statement, and these missing neighbours that didn't get committed before. So let me redeploy. So when we do this, we should now have connectivity between these sites, which we should see here that these start pinging. Yeah, great. So that config has been applied to the devices and is working. So as I just showed, I can now make some further changes. So have a look at what I've just created. So this is our service. If I go on ahead and make a change to here, so if I want to add, say, another device, so I can go into VPLS1, I could add, say, node 4. Let's see what it's going to do. It's going to add node 4 with all the neighbours, and it's going to update all the other devices with the additional neighbour. Another thing as well, I'll just quickly talk about, because this configuration already existed on node 1, it didn't need to create it. So if I go ahead and try and delete this service, sorry, the node command, you'll see that it deletes the configuration of node 2 and node 3, but it doesn't delete node 1 because it didn't own it. We can make MSO take ownership of the service using the reconcile option. So I can redeploy the service, reconcile it, and now MSO has full ownership of the service. And if I try and delete it this time, we'll see that everything gets cleanly deleted, but not the L2 transport statements because they were part of the pre-mod template, which is something that you couldn't do before in templates. If I had a little more time, I would just add a Juniper section to this template. I already have the configuration on one of these devices. Let me exit out here. So one of the Juniper devices, UNX89. So under here, configuration, I think it's on Juniper, it's under routing instance. We've got a VPLS configuration here, so I would do the same thing, display XML template, and I could just simply paste that in to the template, put the substitution variables in there, and we'd also be configuring the Juniper device. But I think with that, I've got messed up a bit in the middle and it slowed me down, so let's leave it at that. I'll hand it back to you, John.
Okay, great, Michael. That's a wonderful look at the templates and a reminder of how easy it can be to do a new service. We've got a few minutes here before our break at the top of the hour, and a couple questions for you, Michael. And it kind of, I think, was timely there a little bit with one of your little glitches, but live demos are always fun.
Yeah.
But XPaths are complicated. How can I make it easier?
Yeah, well, I mean, as you saw, I did make a mistake, just in, a small typo there. I mean, XPaths, are not as complicated as people think, especially if I just switch over here, if you know the YANG model, and I can see it on the left here, it's quite easy to work out your path from here. So I would say, if you can, make sure you understand the YANG model. If you don't, if it's like where I was trying to generate for a device, then yeah, use the display XPath option I was using, and then do exactly what I did. If it didn't work, then use the debug template option. And if you're still struggling, so when you do the debug template and you see the the lines output, it will tell you, as you saw, tell you the current context the XPath's getting evaluated from, and then the result of that. And from there, it should be obvious why it hasn't worked. I mean, I just saw, I made a typing mistake, and that's why it hasn't worked. But if you're still having problems, there's one feature you can do. You can turn tools on in the NSO CLI here, and then in config mode, there's an XPath option, and in here you can evaluate XPaths. So if something's not working, try those things, it's not working as you expect, you can paste the XPath in here and try different variants of it and see, exactly what the problem is that way.
Okay, great. And I as I recall too, we do have up on DevNet in the NSO section in Learning Labs or somewhere there, I believe we have some
Yes.
XPath tutorials as
Yeah,
well that can
I should have said
help
that.
people ease that into it. Yeah. And one other quick question is, can someone write code to calculate the values to use in a template?
Yes, I mean, so you can do quite a lot, as I tried to show just in the template with XPath statements. Um, you can write Python code instead. So to do that, you would have a Python-based service with templates, and you would apply the template. So the call point would be for your Python code to execute, and then you would apply the template from the Python code. And when you apply the template, you can set variables from your Python code that are available in the template. So you may calculate some things in your Python code first, set them as variables. It's just a one-liner. And then inside your template, they're available just as standard XPath variables.
Okay, great. And one final question before we wrap up, not exactly a template, but as you're going along through your demo there, you were doing the package reload and package redeploy. We
Yes.
obviously saw runtime differences between them, but what is the basic difference between a reload and a redeploy?
The package reload reloads everything. I think the reason why it takes longer is because it also reloads all of the schema. So all of the compiled YAM files in your packages, it will go through and reload them, update the schema where necessary, check all of the XPath constraints, and check that everything's still valid. A redeploy you can do in an individual package. It doesn't update the schema. It just reloads your code and templates. So it's much faster. So if you've only updated some of your Python code, or you've only updated a template, in one package you can do a single redeploy and it's super fast. If you've updated the YAM file and you've recompiled it and that results in a change to the schema, then you need to do a full package reload, because the NSO has to validate that there's no that everything's still valid across the CDB, so it takes a bit longer.
Okay, great. And with that, I'd like to thank you for all your efforts prepping for this and given this valuable session.